Introduce
Am I audible clearly?
Yes, yes, you are audible clearly, and we can start the session. Let me introduce you, then we can start the session.
Okay.
I've already made you the co-host, so let us start the session. This talk from Dr. Naveen Saini, who is currently working as a assistant professor in the Department of Information Technology at IIIT Allahabad. He earned his PhD in Computer Science and Engineering from IIT Patna. So from that day also I know him through Dr. Sipanna. So where he conducted research under the guidance of leading NLP researcher like ma'am is there, Asif sir is there, in the areas of text mining and automatic text summarization. So prior to joining Allahabad, he served as assistant professor in other ancient university also like South Korea and France. His research interests include NLP, LLM, automatic text summarization, information retrieval, then machine learning, evaluation and computation, multi-objective optimization. Lots of the things are there. So he has published extensively in reputed international journal conferences, like outside conferences, ranking conferences, mainly on AI-driven solution for the low resource and multilingual languages technology. So currently, Naveen sir leads research initiative at IIIT Allahabad, focusing on generative AI, prompt engineering, multimodal NLP, and LLM-based this application for real-world challenges. So the today's topic, sir is going to discuss about this LLM-assisted multi-objective prompt learning for low-resource language summarization. Thank you, sir. You accept our invitation. So now session is yours. You can start, sir.
Yeah, thank you so much, Professor. Let me share my screen.
Yes, yes, sir.
Yeah.
Yes, sir. Visible, sir.
Is my screen visible?
Yes, yes.
Yeah. Okay. Okay. So as Professor Ranjan already introduced about me, so I am Dr. Naveen Saini. Okay. So I have my lab in my IIIT campus, naming as Information Retrieval and Intelligent Semantic Lab. So we are working in different area like natural language processing, computational biology, and information retrieval. We have too many things like collaboratively. It's an interdisciplinary lab actually. Okay. So today, like, let me discuss about the LLM assisted multi-objective prompt learning for low source language summarization. So that we are naming as the AMPLM. Yeah. So you already know, like in the era of generative AI, LLMs are too much popular. They are able to do the classification. I'm not saying like 100% correct, but they are able to do the classification. They are able to do the clustering. They are able to do the summarizing and too many things. So due to their remarkable, like, performance, they are even no, even like, you can say they are better whenever you want to do some summarization. Okay, for example, a document summarization, they actually performing very very good. So some researchers has also published papers saying that summarization is almost dead. There are no more techniques needed to develop a good summary. They are saying like this, but this is not true because everyone know LLM may hallucinate, and the summary of the quality is totally depend on the like type of prompt provided. So whenever you want to generate summary, the prompt should be like noise free. It should not be ambiguous. It should be clear. It should be grammatical free. That means like it's very grammatically correct. If you will provide some, if we will provide the prompt in an unclear way or in an ambiguous way, then quality of the summary may not be good. And this is very very challenging whenever you are dealing with the low resource language. For example, I don't know Urdu language, but it is very complex. So Urdu is a like morphological it has some morphological complexity. For example, in the English, a word is there play. So possible like variations may be playing, play, played, plays, like this. But if you will talk about the Urdu language, there are too many variations, too many, more than I think 5 to 10 variations for a single word. So that's why it is very, very challenging to write a good prompt which is unambiguous in nature and which is also clear. So let me tell you an example. For example, we have an article: India defeated Australia by 5 wickets in the ICC Champions Trophy final. Rohit Sharma scored 76 runs and was named player of the match. So this is suppose news article. So let us consider different prompt. So first prompt is the read the text and write something about it. So here why it is called ambiguous, because here we are not specifying about the like entity, about what to run, right? For example, read the text and write something about it. So it may generate the output as India played a cricket match against Australia. Rohit Sharma performed well and the team won. Just like basic information. It is not providing how many wickets, how many runs, who was the player of the match, like this. Next prompt, let us assume you give an article, read article, make one line summary, important things right. Now you can see why it is called noisy prompt, because it is grammatically not correct. You give an article, it is not correct. Read article and make one line summary, then important things right. It is grammatically not valid. That's why you can say it is noisy or grammatically incorrect. But when you will pass this prompt to the LLM, it will definitely generate the summary. It will generate, but the summary may be noisy or may not be good quality, right? For example, here output may be India won the match and Rohit Sharma played well. It is also good, but again, I'm not happy like for this such type of summary. What is the reason? That is a noisy prompt. So here issue is a poor grammar, ambiguous wording, important facts omitted. Let us consider another prompt. Summarize the following article in exactly one sentence, focusing on the match result and key performance. Now see this, where we want to we are asking to focus on the match result and who was the key performer. Very, very specific. Now, answer may be India defeated Australia by 5 wickets in the ICC Champions Trophy final, with Rohit Sharma scoring 76 runs and earning player of the match honors. Now, if you will compare all the prompts together, you can see last one is more, because so that's why whenever you want to talk about the summarization, using LLM dependent upon the prompt quality. Now writing the someone may not be efficient in English or in on his or her native language. Okay. Now let me discuss some of the work foundational concept you can say. So there are two different type of prompts. One is the discrete and another is the continuous. So in the discrete prompt, like for example, whatever you are using, you are giving some natural language to the LLM and generating some output. That is actually the discrete prompt. So it uses the natural language phrases, making them human readable and compatible with modern LLM APIs. On the other hand, we have the continuous prompt. So also called as a soft prompt. They are actually the vector base that are powerful but require deep white box access to the model. For example, like as a black box, so suppose you are passing something to the GPT and getting some answer. That is just like a black box. Passing the prompt and getting the output, that is, you can say, discrete prompt. But whenever you are going inside the LLM to see how it works, what are the embedding, what is a vector passed to the LLM, entire thing. So you can say it is a continuous prompt. Now question is that how we can believe on the black box. How we will ensure that whatever prompt passed to the LLM that is correct, that is not ambiguous, that is not grammatically correct. So that's why the rise of powerful closed source model has made white box method impractical. Okay, so we are using discrete prompt, but it is challenging in terms of it like prompt quality. But it is discrete prompt has already written the continuous prompt because they are easily accessible by the end user. So the rise of powerful closed source models has made white box method impractical, shifting the research focus to black box optimization of discrete natural language prompt. Now here is an example, human language instructions. For example, summarize the article in one sentence. So it is human, easy to interpret, API compatible, and search over words. On the right hand side, we have the continuous prompt, that means learns of factors. So we are passing the vector. So they are actually the hidden representation. So it is, you can see this is not the human readable, okay, not interpretable, require model access and search over embedding. That is a difference. But this my session is basically focus on the discrete prompts because they are human readable and easy to interpret. Now, next is the evolution of search-based method. Apart from this, so a major breakthrough was guiding model to perform multi-step reasoning. So in an impressive example, you can see like chain of thoughts, where simple adding the phrase, let's think step by step, unlock power reasoning ability without any example. So we want the answer step by step. That is for the chain of thoughts. Now there is another work that is a GRIPS work by Prasad et al. They use a simple search algorithm like greedy search combined with basic edit operation, paraphrasing, deleting to iteratively improve prompts. For example, we have written one prompt. Now answer is there. Based on the human feedback, suppose answer is not good. Now they are editing the prompt, they are deleting some phrases or paraphrasing and to improve the prompts. That is the logic behind this, like this GRIPS framework, greedy base. Now, if you will write a good prompt, output will be better. That is sure. Good prompt, output will be better. But what about the best prompt? So this leads to the search problem. This lead to the search problem. We have to find, because best prompt can be like any prompt. But how to judge? That lead to the search problem. You can say search optimize. Now on this idea, where we are dealing with this search problem, so there is a framework by that is framework is called the Plum paper. Prompt learning using meta heuristic. So I think it is released in, I think in 2024 or 25, I'm not sure. But it took the major step by creating a general framework to apply more powerful meta-heuristic. So in meta-heuristic approaches, they are the, you can see, they are the random search algorithm. So example of meta-heuristic is called as the, like, is a, you can say genetic algorithm. So any noise is there from my side, Professor? Hello, am I audible? Hello, hello.
Hello.
Yeah, am I audible?
Yes, audible.
Any noise is there from the surrounding?
I don't think so
Okay,
because
okay, then
I have
let
all
me tell you.
muted all.
Okay, okay, because outside like something is going on, like
No,
let me
no, no.
continue.
I have muted everyone.
Okay, okay, fine then.
Yes.
Yeah. So, so here, so Plum framework is there, which is based on the materialistic technique. So materialistic technique are the random based search algorithm. So an example is the genetic algorithm, which is inspired by the biological phenomena of the human being. For example, parents are there, their children are there, then their children are there. Like it's a biological phenomena among the human being. So based on that phenomena, we have the genetic algorithm, and there are too many algorithms are there, like differential evolution, particle swarm optimization, like this. So they are the search algorithm. Why I'm discussing this? Because to find out the best prompt, we are considering this as a search problem. And based on the search problem, Plum is a framework which is really recently developed. So this Plum was showed that established optimization algorithm could be highly effective for finding out the best prompt, or you can say strong prompt, for a wide variety of tasks. Task may be classification, task may be like clustering, task may be summarization, or task may be like maybe any other task you can say. But here was what was the challenge? Because it is a search problem, it is an iteratory procedure. In every iteration, for example, in one iteration we have 10 prompts, so it will find out the best prompt, then go to the second iteration, then again it will find out the next best prompt, and keep on doing this until we will find the overall best prompt. So what was the limitation here? It focused on a single objective, because search problem, in the search problem, objective is very very important. Based on what objective we want to find out the best prompt, and this Plum algorithm was utilizing only the single objective. Single objective, for example, in the prompt what we want, it should be grammatically correct, it should not be ambiguous in nature, it should not be noisy. So there are different perspective to measure a single prompt. Now this Plum framework using only one perspective instead of all these perspective. For example, the machine learning, so we have different measures like accuracy, precision, recall, F measure. If we want to improve the classification accuracy, suppose we are focusing only the F measure, not the accuracy. But if we are focusing on more than one measure, that is a multi-objective. So the key limitation was it was focused only the single objective, optimizing for a single performance measure. So this overlook other critical aspect of the prompt quality and leads directly to the gap our research address. Now this is the general idea behind the genetic algorithm, which I have just written on one or two slides. What is genetic algorithm? It's a methodistic algorithm, and it's a population-based optimization technique inspired by the principle of natural evolution and survival of the fitness. So I told you, it is inspired by the biological phenomena of the human being. So currently, there are set of parents are there in the world. Okay, set of parents, like different parents are there. Every parent had their children. Now, out of those children, only those children will go to the next generation, which are best in terms of the objective function. Now, objective function is totally dependent on the type of problem. For example, we can say classification. Suppose we are dealing with a classification problem, so we want to optimize the classification accuracy, maybe. So it will start with the population of the candidate solution. Here, parents are there. Then evaluate the quality of the solution. We will evaluate the quality of every parent. Then select the best solution for the reproduction. Now out of the parent, we will select only those parent which are best for the reproduction. That means for generating the children's. And then Using these two operators, crossover and mutation, we will generate new children. What is crossover? Crossover is the exchange of genes between the parents. But mutation means small random changes between the gene. And then now we have the parent, we have the children's. Now we will evaluate the fitness of the children. Out of the children, out of the parent, only those will proceed to the next generation which are better in terms of the quality. And this process we will keep on repeating until multiple generation or until a certain threshold. Now, what is our goal here? Gradually evolving better solution by retaining useful characteristic and discarding poor ones. So you can see here, out of the good candidate solution, out of the new solution, we are propagating only the good solution in the next generation. Now the good solution keep on propagating up to the next final generation, and we can find out the best solution at the end of the generation. Now this is the workflow. We have the initial population, we have the fitness evaluation, then selection means selection of the parents for the reproduction. Then we have the crossover mechanism, that means exchange of genes between the parents. Mutation means change in the gene. Then we have the new population of the children's. Then this is the loop actually continue. I forgot to insert a like a loop here, but loop is there. And then we have the termination condition. Now what we will achieve at the end? We will achieve the best solution found after several generations. It's an iterative procedure. Now I have discussed in one example how to do this, how to apply the crossover and mutation in terms of the prompt, because our ultimate goal is to improve the prompt quality, to find out the best prompt to generate the good summary. Suppose prompt number A is summarize the article. Prompt number B is generate a concise one sentence summary. Now we will perform the crossover between these two prompts. So what is crossover? It is the exchange of genes between the parents. What you can see? So crossover is there between these two. Like you can say, summarize the article is taken from this one. In a concise summary is taken from this prompt number B. A concise summary, you can say. This is a crossover. In the mutation, what we have done? We have done the random change. Either we can rephrase, we can delete something, or we can append something. So here you can say, generate a concise one sentence summary that capture the main event. So we have done the mutation here. Now crossover combine useful instruction, but mutation introduce small modification that may improve overall performance. This is the general logic. I will show more step, like I have some like bigger example, bigger than this. Now I have discussed why we want to improve the prompt quality. And then I have discussed few of the like existing work. Now, based on the literature, what we have identified, so the existing work, which was the Plum work, is optimizing only the single performance score instead of having the multiple perspective, or you can say ignoring the prompts on linguistic quality, which can lead to the brittle and unnatural prompt. Second thing was lack of language aware design. The Plum framework was tested only on the English language. It does not adapt to the morphological rich language like Urdu and the other slow resource language. And last one was the limited evaluation scenario. How we will make ensure that whatever prompt achieved after the optimization, that is good in quality. Either human feedback needed or some automatic measure. So to add this gap, yeah, one more thing. So to add this gap, we have developed a technique that is called the MPLA, multi-objective prompt learning using meta heuristic. What is multi-objective here? The first one. Multi-objective means optimizing more than one objective simultaneously. For example, let us consider a solution x is equal to x1. Like this is the dimension. Suppose another dimension as there. You can say like these are the features. Okay, features. This is the solution. So what we want to do? We want to optimize multiple objectives together. For example, f is the set of objective for this solution. F1x is the first objective. F2 is the second objective. Fm is the mth objective. So we want to optimize multiple objectives together. Maybe all the objectives have the minimize, all the objective may be maximize. A mixture of and maximize. For example, when we are going from like Delhi to Odisha, what we want? We want the maximum comfort in the train, but minimum time taken by the train, right? So these are the two different objectives. Some more objective may be there. Having some constant. For example, we are imposing the constant like that. The train should have the penalty, kitchen, like you can say like, what should I say? Pantry car, right? So these are the some constant. For example, gix greater than equal to 0. There are constant, there are p inequality constant, and there are q number of equality constant. So what is the key challenge? Improving one objective may deteriorate another objective, resulting in a set of trade-off period optimal solution. So whenever we are optimizing more than one objective together, it may be possible that one objective decreasing the performance of another objective, and second objective may decrease the performance of the first objective. This may be true because if you think about the train example, to get the minimum, like train having minimum time and maximum comfort is very difficult. So that's why always there is a trade-off between the different solutions. That is called as the period optimal solutions. Now there is one more concept is there, concept of domination. So let us assume two prompts P1 and Pj. Prompt Pi dominate Pj, but when prompt Pi dominate prompt Pj, when prompt Pi is at least as good as Pj in all objectives, and Pi is strictly better than Pj in at least one objective. So there are two conditions. So let us understand this one using example. Therefore, they are prompt A, B, C. Somebody quality score is 88, 84, 91. Some number score is 92, 91 like this. Okay. So they are, this is the table. They are the two different objectives which are measuring the quality of the prompt in terms of grammar and summary quality. So summary quality here we are measuring, there are multiple measures. I will discuss in the coming slides. Suppose for time being, consider these are the two different objectives having the different score. So here prompt A dominate prompt B. Prompt A dominate prompt B. But what is the reason? So prompt A, you can say in terms of the summary quality, its score is prompt A has the high score as compared to the B. So here you can say second condition is fulfilled. Pi is strictly better than Pi in at least one objective. So you can say at least one objective. But for the grammar score, it is both having the equal score. But in terms of first objective, A is better than B. So that's why prompt A dominate prompt number B. Now what about prompt B and C? Prompt B and C, you can see summary quality score of the prompt C is better than prompt B. But in terms of the grammar score, summary quality, grammatical score of the prompt B is higher than prompt C. In one objective, C is higher. In the second objective, B is higher. So both are non-dominated to each other. So in my session, what I will do, I will adopt an algorithm called as the NSJ2. It is quite old, but we are just want to investigate this thing. So this algorithm, non-dominated genetic algorithm version number 2. So non-dominated sorting means it uses this concept, domination and non-domination concept. And genetic algorithm, already I discussed the brief about this genetic algorithm. So it is multi-objective in nature. Now in our Emplum framework, what we want to do actually, we use the non-dominated sorting genetic algorithm to evolve the prompts. Now what we are optimizing two objectives simultaneously for a prompt P. First one is the summary quality and is the prompt grammar. Now how we are measuring the summary quality? So summary quality, we are using two different measures. One is the Rouge L and the BERT score. Rouge L measure the overlapping of words between the generated summary after providing the prompt and the gold summary which is available with us with the data set. And BERT score measure the semantic score between the generated summary and the gold summary. So here we have used the weighted score from Rouge L and BERT score on the generated summary. While prompt is the grammatical score measuring the grammatical quality of the prompt. That means it validates how the prompt given is, whether the given prompt is grammatically correct or not. It is an LLM based score because LLM are efficient in calculating whether the particular sentence. Lot of options are there. So overall, there are three objectives, but we are utilizing two objectives only. First objective is the weighted combination of the two different measures, and last one is the second one is the grammatical score. So we are maximizing these two objectives for a prompt P. Now, what is our problem formulation? Our goal is to find out the best prompt P star, you can say, multi-objective search problem. So the existing Plum framework was based on a single objective. Now we have converted that framework to the multi-objective search problem. So here the best prompt is identified based on two objectives, not the single objective. So one is the maximize summary quality, and another is the maximize prompt grammar. So this is the overall framework. You can have a look on this population. Initialize the population. So in the initializing the population, we are considering three different scenarios. Suppose I want to give the prompt in Hindi language, and I am very much efficient to write the Hindi language. But other person may not be efficient in the writing the Hindi language. The person know Hindi language but may not be efficient in writing the good prompt. Like कुछ टूटा फटा prompt लिख रहा है. For example, मुझे इस डॉक्यूमेंट की समरी चाहिए. और उसने लिखा मुझे समरी एक डॉक्यूमेंट की just like you can say. So we have considered three different scenario. Good to good means like all the
Dr. Naveen, your voice is breaking.
Prompt in
Dr. Naveen, your voice is breaking. Hello?
initially
Hello, am I audible, Dr. Naveen? Hello? Some network issue. Am I audible, Dr. Naveen? Hello? Hello? Am I audible, Dr. Naveen? Unmute yourself.
yeah. Am I audible now?
Yes, 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 audible. So I think some problem is there, network issues.
Yeah.
Okay, now you can share
Yes.
the screen again. My voice is breaking actually, that's why.
Some network, some I don't know what is the issue. Okay, anyway, so
Reshare the screen.
let me start.
Share the screen
Yeah,
again.
I'm selling this. Yeah, is it okay now?
Yes, yes, it's coming.
Yeah,
Yes, yes, now it's visible. Yeah.
am like, is it?
Voice is still breaking a little.
Yeah, yeah. I think my net is okay. So it is even breaking.
Yes, now it's okay.
Hello. Okay.
Now it's okay.
So yeah. So I have just changed my network. Anyway, so I'm discussing the Emplum framework. So because this Emplum framework is based on the genetic algorithm, so here what we are doing, we are first step is to initialize the population. So here population initialize can be done in a three different way: good to good, worst to good, and multi-good. So in worst to good, what we are assuming, the person who is writing the prompt is not good in writing the prompt. So all the prompts written initially are not good. And then good to good means like prompts are, like all the prompts are different in nature, but all are good actually. All are diverse in nature. In the multi-good, what is the scenario? Initially, what we are doing, we have the good prompt in the beginning, but because the population have a like set of parents are there, so all the prompts are look similar to each other. Now, what we want to do, we want to optimize them to find the best. So this is the initial population scenario, three different scenario. Now, in the next phase, what we are doing the prompt parsing. So not that whatever framework we have developed, that we have developed on the like two language. One is the English, that is a that is not the load says, but Urdu is a morphological complex language. So we are doing the parsing. So parsing means dividing the prompt into different chunks, so that we can perform the mutation and crossover and deletion easily. Okay, I will show some example in the next slide. So this is the prompt parsing. Now, because initially we have the set of candidate solution, in the next phase we will do the parent selection. That means who will become the parent. So there are too many techniques to select the parent. So like for ruler wheel selection is there, rank based selection is there, random selection is there. Then we will perform the evolutionary operator, that is a crossover. After performing the crossover, we will evaluate the fitness score. That is a like whatever, because we are assuming two different objective. First one is the summary quality and as a grammar score. So grammar score we are achieving with the LLM based scoring. After that, we are updating the population. Because after performing the crossover, we will have the subtype of new solutions called as a updated population. This is the initial population, which is the next population we have. Now what we will do on the updated population, we are performing some mutation. Mutation means whatever solutions are generated, either we can rephrase them, or we can add some paraphrase, we can add some phrase, or we can delete some phrase, or we can swap some phrase. Alteration you can say. And after evaluating, we are, if some change is there, we are evaluating. So maybe some solutions are changed. So again, we are reevaluating the multi-objective fitness. That means summary quality and grammar score. Now, after this, like after having the initial set of population, after having the new set of solution, we will apply the NSG2 algorithm. Which will select the top best solution out of the initial population and the new population. Initial population suppose have the 10 solution, and this population may have the 10 solution. Then out of 10 plus 10, we will select the top 10 solution based on the fitness value. So here we will apply the domination and non-domination concept. After selecting the, like this top best solution, we will move to the next generation. If termination condition is achieved, then then we will get the here termination condition can be the in terms of the number of generations. Suppose we are keeping the number of generation as 50. We will keep on continue the iteration. If number of generation are like achieved, then we will get the set of Pareto optimal fronts. Otherwise, we will keep on repeating this. And finally, we will find the best candidate prompt from the available set of prompt. So this is the overall flow. Now let me talk about the, so here like as I discussed, so in that we have discussed the three different scenario. In the good to good, what is our goal? Can the framework refine an already strong, grammatically correct prompt to achieve even better performance? So initially what we have passed for this population initialization, what we have passed the strongly good and grammatically correct prompt. So they are what we how we are doing this? Either we are generating the prompt manually, and also checking its quality using the this LLMs to make it strong enough. Worst to good. In worst to good, we are our goal is to, can the framework take a poorly written prompt and evolve it into a high performance one? Poorly written prompt, okay. This test will check the corrective power of framework from a low baseline. And last one is the multi-good. In the multi-good, we are doing this with English only because there is some reason is here. So here we are starting with a diverse set of several good prompts. Now goal is to, can the framework discover superior variants through different combinations? Now we have omitted this multi-good from the Urdu language due to this morphological complexity. Now let me discuss the crossover and mutation procedure. Suppose parent 1 is there, parent 2 is there, parent 1 and parent 2 is there. Please read the article and write a brief summary that captures the main idea. So if you remember, we have done the parsing here, right, for the English and Urdu language. So if you will see here, in the bracket, this is one phrase, second bracket is the next phrase, and this is the third. You can say chunks. So this parsing is done by some available tools. Similarly, the pair parent 2 is there. Now, how we perform the crossover? To perform the crossover, you can say crossover is the exchange of genes. So here we are considering this chunk as a 1G. And this like striker is showing that like it is like like you can say that after the performing the crossover, only black line comes as a new children, or you can say offspring. Please read the article and write a brief summary focusing on the most important information. So this is the offspring. This is the crossover example. The mutation example is, for example, consider this prompt, read the passage and write a summary in your own words, highlighting the main idea. For the mutation, we are using four different things. First one is the delete. Delete some chunk based on some random probability. Read the passage and write a summary highlighting the main idea. So this phrase is deleted. For every chunk, where random probability is generated, and the chunk which has the highest probability, that is deleted. We are deleting. Not that it may be possible that whatever we are deleting, that prompt may not be good. Now, second, like mutation, we are doing the paraphrasing. Read the passage and write a summary in your own words, focusing on the central thing. Here you can say this phrase is added. So here we are using the LLM to like rephrase it. Now addition means, so they are like actually paraphrase and addition are like somehow like like you can say similar to each other. So paraphrase is done by the LLM, but addition is done by like you can say. So for example, read the passage and write a summary in your own words, highlighting the main idea. So this phrase is added. Okay, you can do like some other thing for the addition. Either you can use one of them or maybe add something like which is suitable for this sentence. And swapping means in this offstring, in this solution, you are swapping something, right? For example, highlighting the main idea, you are going like taking it at the second place and write a summary at the last place. Exchange of the genes, like random change, you can say. So for the mutation, we are doing these four different concepts: delete, swap, paraphrase, and add. And the crossover, this exchange of genes, this is the new solution. In this way, we are generating the new solutions. So procedure start from here, starting from the candidate prompts, worst to good, multi-good, and then like dividing into the parsing the candidate prompt, then applying the evolution search, and then generating the new solution, then evaluating their quality. Like this, we keep on propagating until we get the best. So this is the overall algorithm, like multi-objective prompt evolution. We'll start from the like prompt. We start from the population size of n. That means how many candidate solution we want. Number of generation, mutation probability, target language, for example, what we want, and if it's language we want to generate the output. Now output will be the single base prompt. Okay, because I already illustrated this process in the like flow chart, so I'm just avoiding this thing. Now regarding the evaluation, we have chosen the summarization task. Already some data sets are available along with the natural instructions. So first data set is the XSUM, another is the XSUM. So XSUM is the only in the English language, but XSUM is the English and Urdu and many other languages. So first we have evaluated the like performance of task on the English language, then on the Urdu language. And for each data set, I think more than 1,000 samples are available, but we have chosen only 250 samples from every data set. Note that this framework is not Supervised in nature. Supervised means it doesn't need the label data for the training. However, for the evaluation, we are using the label data, okay, but not for the training. That's why we have chosen only the 250 samples from every data set. We are not training the anything. Okay. Now this is the data set statistics. Language English, Urdu. Samples are 250 for everyone. Number of sentence, you can say minimum is 134. Maximum is 129, 128, 54, and average is like this. Similarly, in terms of the words, minimum is 29 and average is 379. For the actual sum, minimum is 58, max average is 442. And for the actual sum, minimum is 119 and average is 144, 482. And this is about the number of like sentence length in the actual summary which is available with us. Because this is totally the abstractive in nature. So there are two different types of summary. First one is the abstractive, second is the extractive. In the extractive summarization, the summary, the sentence should be selected from the existing document only. No change. But in the abstractive summary, paraphrase needed. Okay, paraphrasing needed. That means we have to construct the new sentence from the original one. And whatever we are doing, that is abstractive in nature. So that's why if you look over the minimum number of sentence in the summary, that is 1. And maximum is 153. And average is almost 1, you can say. Yeah, 1.5. In terms of number of words, minimum is 3. Now you can assume it is like summarizing the document minimum 1 words and maximum 39 words. Minimum 3 words are also there. Okay, minimum 3 words, then 7 words, then 14 words. You can assume like how the long document is it. Now, so these are the results on the English language, considering 3 different scenario: worst to good, good to good, multi good, worst to good to good, and multi good again for the D different set. And we have to utilize the open source like LLMs like Llama 3.18b, Quen 3, Mistral 8b, Quen 2.5. Because again, like what is our goal? We want the like good quality of prompt that is not ambiguous in nature, that is grammatically correct, that is not noisy. That is our goal. So that we have chosen the different LLMs. Now you can see this is the summarization score. The summarization score means which is the weighted combination of the Rouge L and the grammatical score. This is the initial, this is the final. You can see the summarization score is achieved like initially it was 44.97, then it is increased to 47.64. In all the cases, it is increased. Weighted combination of Rouge L and Bird score. And then we have the grammar score. So initially you can say 20, 10, 70, 65. We are going for worst to good. Prompt are initially worst in nature. But now it is greatly improved. But the prompt, which is already good in nature, you can see, well, good to good, the score is not too much improved, 90 to 91, because they are already good in nature. Obviously, logically. Okay. Now, in the worst to good Excel sum, 20, 10, 90, 65, it is the grammatical score is already improved. You can see. Now, this is the Rouge score. Now, because summarization score is a combination of Rouge and the Bird score, you can see them individually. So, Rouge score is like initially 18.20. So, it makes the longest common sequence between the actual generated summary and the gold summary. It is the F1 score. So, initially it was 18, it increased to 20.85. Using Quen, it is 16.49, it is increased to 17.51. So, in all the cases, it is improving. Similarly, is the Bird score, because summary score you can say like on Bird score almost similar but slightly improved. But the word overlapping is greatly improved, you can say. Now, this is an example or the English language. Because Llama 3.1 is out of these one, Llama 3.1 is performing good. So worst to good, you can say initial prompt are you given an article summarized in sentence. So the quality is not good. The initially root score was 18.17, but after optimization, you can say the final score was 20.85. You will be given an article to work with condensed into a single sentence. So it is much better than this initial prompt. So good to good, you will be given a text, read, understand, provide a summary in a. It is good actually. But obviously, like after optimization, you can say you will be given a text, summarize the text in a single clear sentence. That is also good. And here the root score is greatly improved. Last one is the multi-good. So in the task, you are given an article. Your task is to summarize in a sentence. So for this task, you will get an article, summarize its main idea in a single sentence. Here also like score is improved. So that is how the English prompt evolved. Now coming to the Urdu language, which is morphological complex language. Due to the because a root word may have like too many variations. So here we are like some LLMs are different because whatever LLMs are used in the English that are not like all the LLMs are not trained on the Urdu language. So that's why here like Bloom's this is different from the previous one and Gemini here. So again here you can see the summarization score. Initial score was this one like 49, 49.14, 49.13. So all are increased to approx like 48, ranging from 48 to 57. Similarly, the grammatical score is also improved. Doodle score is also improved, and similarly the bird score. Excluding this one, this is like insignificant. You can see because I don't know the Urdu language, but like it's just a demonstration. Like because Gemini 2.2 flash is a better in term like, out of these ones in both the cases. So good to good. Like this was the prompt. Root score was this one. So now root score was greatly improved by 35.663. In the worst to good prompt was this one. Root score was this one. So this is greatly improved by like increase to 28.22. So in all the cases, worst to good, was good to good, or multi good, prompt is improved in terms of the summarization quality and in terms of the grammatical score. Now, like because there are like like you can say there are some open source tool available like MBART, MD5, multilingual. People are even using. They are outdated, but the people are using. So we have compared those things, and here we can say like the Gemini approach is getting better. Like this emblem framework, you can say is better as comparison to the existing language models, MBART and MD5. Similarly, for the English baseline comparison, we have XSum and XXLSum. So here BART is better, but when we will look over the multilingual summarization, so our Llama is better in terms of the BERT score and the BLUE score. So Rouge 1, Rouge 2, Rouge L. So here Rouge score means like matching the overlapping of the birds between the generated summary and the gold summary. One means 1 overlapping. 2 means 2 gram overlapping. L means longest common sequence. And this is the model-wise performance overview. Initial versus final Rugel, Bird and grammar score for English. So all the cases you can say red is the final and blue is the initial. In all the cases, in our Emblem framework, Rugel purpose is increasing. This is the bird performance. In all the cases you can say, all the cases it is increasing. It is slightly increasing but increasing. About the grammatical performance, you can see in every case it is greatly like improved. Similarly, the Urdu performance overview, initial versus final Rouge score, BERT and grammar score. You can say Rouge is totally increased, BERT score is also increased, grammar score is also increased. This is a visualization like score. Now, to check whatever quality, whatever summary is generated. Okay, we are unsure about the like we can make answer about the prompt quality. It is improved as per the like summary quality, as per the summarization, as per the like you can say summarization score and the BERT score. The summary may be improved, but how will ensure So to justify the reason, we have like evaluated these the summary generated across two different dimensions. First one is the human validation. For example, I am evaluating whether the summary quality is good or not. And second is the LLM as a judge. So we have chosen the GPT-4 to evaluate. GPT-4 was not common among these, like whatever LLMs are used. So we have used GPT-4 to evaluate the quality of the summary and the human being across different measures. So first is the readability, second is the relevance, third is the grammar, focus, consistency, coherence, interpretation, and fluency. Readability means the summary can be readable or not. Relevance means degree to which the important information from the source text is preserved. Grammar means correctness of a grammar, punctuation, and sentence structure. Focus means focus on particular some topic. And consistency, absence of the contradiction and logical inconsistencies. Coherence means logical flow and connectivity between ideas. Interpretability means how much you are able to understand to have its like meaning. And fluency means naturalness and smoothness of the desired generated text. So the human and the LLM are rating the generated summary between 1 to 5. Higher the score, that means more is the quality of the metric. More, you can say more good is the summary. So we have like evaluated these 7 different measures on the summary generated on the 50 random articles. So this is on the English language. You can see. So this is the average score actually. Average score across all the measure. So initially it was 3.5, 3.0, 2.7 before like optimization. But final score was you can say 3.2, 3.8, 3.8. In almost all the cases, either equal, yeah, but most of the cases, the final score is increased. Similar way was the judgment by the LLM as a score, LLM as a judge. So initial score was this, but final score was this. And then on the excellence data set, seem like most all the cases, again human score was better than the existing ones. And maximum score was you can say 3.8 using Llama. In case of multi-code scenario, in case of LLM score, maximum score was you can say 4.2. Again, in case of Llama 3.1. And this is the score using the Urdu language. You can say human score was 4.1 in case of Gemini, 4.0 in case of Gemini. Yeah, greatly improved. Not in other cases. They may not be good on the Urdu language, but Gemini is performing very better, much better than the other LLMs. Similarly, with the LLM score, it is 4.75, beginning from more than 1%. Now, because I told you, whenever we are more optimizing more than two objectives, more than one solution may appear, come into the picture. Set up non-dominated solution, we can say. Is it visible like this? Can like yes? Should I make it big?
No, it's visible, but that caption is not.
Okay, let me do this. So this is the iteration number 1. You can say actually like whenever like in the non-dominated sorting we have different fronts. All the fronts have the different rank. Front 1 maybe have the rank number 1, front 2 rank number 2, front 3 rank number 3, front 4 rank number 4, like this. And all the fronts may have the set of non-dominated solution. For example, you can see these two solutions. This yellow color 98 and this one. These two solutions, okay. So these solutions are non-dominated to each other. Why? Because like on one axis this is a grammar score, other axis is the summarization score. See this score. See this solution. This solution is better in terms of the summarization score as comparison to this solution. But this solution is better in terms of grammatical score as compared to this solution. That's why they are non-dominant to each other. So this is the front number four. Similarly, front number five is like here, and other fronts are all like you can see like so. Whenever we are, whenever we are optimizing more than one objective, so we set of non-dominative solutions come into the picture, and we are making the cluster of the different cluster of those solutions such that every cluster has a set of non-dominated solutions like this. So in this way, we are keep on optimizing. You can say initially we are here, now we are reached to up to here, having a good grammatical score and the good summarization score. Like discuss, we can discuss later if like a question permit. Question is there. Obviously, we have to find out the best solution among them. So this is the range of scores we have shown using the box plot. Range. So this is the average usual score using on the English language, 18.54 to 20.85. This is the median. Okay, this is the median. You can see average score is approx 19.95. You can say, and this is the again like so average rouge L. Okay, so they are actually they are the three different scenario: worst to good to good, and multi good. Okay, so in every case we have shown the box plot. Now this is the performance distribution on the Urdu language on the two different type scenario: worst to good and good to good. Now this is the like summary example. This is the like this is the Urdu language. You can say actually we write from the like ending like go to the beginning like this in the reverse way. This is the English translation. You can say predicted summary is the 7 Indian films will be screened at the Cannes Film Festival starting in France this year, with actors like Aishwarya Rai and Shilpa Shetty also participating. Gold summary is 7 Indian films will be screened at the Cannes like this. Same type of scenario you collect. And the English scenario, this is the Urdu scenario. Just a like snapshot like whether like our architecture able to like go. So I have the time, Professor. How much time you left? Like I have some more like
I think 20 minutes. 20 minutes.
14.
So 20 in 130.
Okay, okay, fine. So here, so this is the like this is about the Amplum framework, multi-objective prompt learning using meta heuristic. So the code is also available with me. If you have like some question regarding that code, it is openly available because this work is already published in one of the SCI journal. So maybe I will communicate later with the Professor Ranjan. You can maybe he can distribute with you. So if you want, maybe I can discuss it later with the question answering. But I have some few more like prompt optimization technique which I would like to discuss. Now there is a like one more technique is the zero shot prompting framework. It is not the optimization. Why I'm discussing because like some other techniques are there which are based on this technique. Zero shot prompting framework means like you are providing a prompt to the LLM and then asking the one the answer. That is just zero shot in a zero shot way. So here LLM perform a task based solely on the natural language instructions without being provided with any task specific example or demonstration. We are not providing any task specific examples to train it. That's why it is a zero shot. For example, if I want to generate a summary, I will provide an input document and ask the LLM, please generate the summary. But again, here question is on the prompt quality. That is not the scope of this zero shot prompting framework. That you can optimize using the either Plum framework or Plum framework. Now here like flow diagram is there, input document is there. You will provide the zero shot document. Here LLM is there and summary will be generated. Just simple. Now we have another technique, iterative self-prompting framework. Iterative. So it's a iterative self-prompting, which is a feedback-driven prompt optimizer. Why I'm discussing? Because you can consider these like techniques as a baseline to the Plum and mplum framework. All codes are available with me. I will share it later. So iterative self-meta like is a like feedback driven prompt optimizer. Feedback driven means like some feedback was given. For example, I have given the prompt and I received the output. On that output, some feedback is provided so that the next iteration summary can be improved. So it's a feedback driven technique. It will start from the initial prompt and LLM generate output for all the evaluations. For example, let me like illustrate this procedure using the flow diagram. So initial prompt is there. I have provided the LLM. LLM will generate the summary, right? Now you can evaluate the score of this summary using the bird score and the row score. Okay, you already know, like I already discussed this thing. Best prompt some memory. So here it is keeping the so score is there. So is the best prompt memory. So currently score is this one. Suppose it may not be the best because some iterative procedure. Now there is a critic module is there. Critic module. Okay. Again, it's a totally blind box. So what you will do, you will ask the LLM, this is the bird score, this is the root score for this input document. Now, identify the weakness of this summary. For example, identify the weakness of this summary generated based on the bird score or root score and provide the new prompt. Provide the new prompt. Okay, so this critic module will identify the weakness. And this patch module will improve the prompt based on the weakness. Now we have the refined prompt. Now refined prompt we will give to the LLM. It will generate the summary. Summary will be again evaluated using the bird score and row score. Now it may be better than the previous or may not be better. May not be better. It may not be better. That is will not be stored. And now we will again like ask the LLM. What is the critic model is there? What are the weakness based on the bird score, root score identified for this document? What are the weakness? Then refine prompt will be refined. Then given to the LLM like this. So keep on iterating. At the end, we'll get the best prompt. But here, a question may arise in your mind. How, based on the bird score, which is the similarity score between the generated document, the actual document, and root score is the overlapping of word between the actual and the generated, how it will determine the weakness? How it will determine only the weakness based on the numerical values? We are not providing the actual summary here. We are only providing the numerical score. So here may be possible that in the multiple iteration also, you are not getting the best prompt. But you will get the output, that is sure. But some in one iteration prompt quality is good, summary quality is good. In another, summary quality may decrease. And in third one, summary quality may increase. So just like a blob because of the blind box. Black box, you can say. Yes, any questions? Any questions?
Questions? You can unmute. I don't think so, Miss.
Okay. So one more technique is there. Yeah, this is the iterative self-prompting. Now you can say I have some example. For example, write a concise clinical summary of the following case report covering. It's a medical example. Like I want the clinical summary having the patient demographic, presenting compliant, clinical finding, diagnostic, treatment plan, clinical, use clear professional medical language. So it will generate the summary. I have provided this prompt only English language, but you can adopt to the low resource language. Currently my student using the same thing in the code mix language. So it will generate some output. It will give the some score. Now, this is a critique provided by the LLM. The prompt does not specify the importance of including all critical details of the each section, which can lead to omissions. Lack of emphasis on the necessity of the using clear professional medical language might result in suboptimal phrasing and terminology usage. So this is the critical. It is the weakness. Now, in the next iteration, what we'll do? Prompt will be refined based on the previous weakness. Now, again, we will evaluate the score, and then we'll ask the LLM to provide the critic score, critic like weakness. Then in the third iteration, prompt will be refined, and the bird score will be increased. Now, if you look over here, ISP performance. So initially, iteration number two, iteration number one, bird score was 85. Iteration number two, bird score was 8576. Initially, it was slightly increased, slightly. And in the third iteration, it was decreased. So as I told you, because it's a black box only, and it is you are not providing the actual goal summary, you are just providing the numerical information based on the evaluation measure. So that's why like performance may decrease, but maybe increase if you will provide the gold summary instead of the numerical value. But that will be in supervisory nature. Now you can similarly the case of rules and score. Item number one, this is the rules 2 and rules. Initially, this was the score. Then in the next iteration, 3343, 3325, it is decreased. 1181, it was the rules 2. It is 1151, it is also decreased. 2253, it is 2227. It is best, but not slightly, not significant too much. Okay, so it may decrease or increase based on the evaluation issue. Next technique is the automatic prompt optimization. So in the automatic prompt optimization is again a search-based prompt engineering framework that automatically generate, evaluate, and select multiple candidates to discover the most effective prompt for a task. For example, let me discuss the architecture. This is the last one. Then I will move to the ending. So this is the initial prompt. You will pass to the LLM. It will generate the summary. Now you will evaluate again the bird score and row score. Now critic score will tell you the again weakness. It is a modified version of the previous one. If a critic model will tell the weakness and improvement suggestion. The patch model, what it will do, instead of one, it will generate the 3 candidate prompts. Candidate number 1, candidate prompt 2, candidate prompt 3. But it's a because it's a parameter, you can also generate the 5 prompts, you can generate the 10 prompts based on the weakness. But because we want to minimize the time as compared to the previous one. In the previous case, only one prompt was generated, but here we are simultaneously generating the multiple prompts. So again, we will pass this prompt to the LLM, will generate summary, then evaluate on the score, and then see which one is the best prompt. Then again, if iteration completed, yes. If not, we will provide it to the critic module, which will identify the weakness of the best summary, you can say, or best candidate, and then pass module like this, it will keep on iterating. When the iteration are over, it will go to the best prompt repository. We will do the final evaluation on the full data set. Okay, after finding out you can do it on the 50 samples. For example, suppose I have the 1000 document in a data set. You can do it on the 50 samples and then replicate after finding out the best form, you can generate the result on the 150,000. That is possible. For example, like this is the thing, this is the example, prompt number 0, prompt number this, bird score is this, row score is this. In the P1, it is slightly increased. Prompt number 2, okay, you can say it is also increased like this. We have some of the multiple prompts. So P6 is better than, like you are able to find out the P6 is better in terms of the this bird score and row score. Okay, because it will be stored parallelly using this best prompt repository. So this is the prompt performance for the automatic prompt optimization. Like you can see the competitive score 85. This is the bird score actually. Bird score 8520, 852324 like this. So slightly increase here, then going down. Because it's again it's a black box. So here you can find but at some iteration you may get some good performance because prompt is optimizing just like a black box. And here also like Rouge is improved. Okay, so that is about the automatic prompt optimization. Now I'm coming to the conclusion. So we have introduced the Emblem framework, which is the novel multi-objective version framework, tested on the English and Urdu language. Urdu is a low resource like morphological complex language. So we have jointly like optimized the summary quality using the grammatical score and the summarization quality. So we have we are able to know that from the like experiment. So it is working well enough on the Urdu language. However, we have not tested on the other language. Okay, for the framework delivered Rouge improvement up to 2.6 point for English with Llama 3.1 and a remarkable 12.09 for Urdu language using Gemini. So it is yet to be tested on the other language because my students are currently exploring the other language in parallel, like Hindi language and code mix language and Tamil language, Malayalam language. Malayalam language we have already tested, but the work is under like what is already communicated and it is under revision. And apart from this, I have discussed about the some like from prompt optimization technique like instruction set optimization and automatic prompt optimization. So the all the codes are having with me. If you want, you can drop a mail to me. I will share with you. Yeah, thank you so much for the attention. Now I'm open for the regarding my future work. Yeah, I already discussed. We are extending this thing to the other LLMs, also the more for other language, and we are also experimenting with the other metaheuristic technique like gray wolf optimizer, differential versal mayfly optimization. Because there are a lot of techniques that keep on coming into the nature, into the scientific publication house. So we are keep on exploring like how much like this algorithm is better perform, like when we use the different metaheuristic technique. Now, thank you so much. I am these are the some set of references. Now I am open for the questions you may ask. You may raise some query if you have. Thank you so much.
Thank you, Dr. Naveen. So, as Dr. Naveen said that you can ask for the code from him if you want to run or you want to test it in different languages. Okay, in which languages he belongs. That is one thing you can do. Otherwise, I think Dr. Naveen, it is uploaded in GitHub or no? Code is not available.
Yeah, GitHub is there.
Okay, you can share the GitHub.
I will share my slides and the GitHub link with you. Or maybe
Yes,
so like participant can access this.
Okay. So any question from the participant side, you can just unmute yourself and you can ask the questions if anything is there. Yes. Anyone? Erika, Subhadra. Anyone?
Yes, sir.
Yes, yes.
Yeah, sir. It was really very informative and knowledgeable session. Sir, as you have told, our goal is to select the best prompt, right?
Yes.
So, of course, it is one of the search problem. So, can we apply this one is the machine translation problems, means will if impact on that for improvement, like our
Yes,
low
yes.
resource language?
Yeah. So if you are like translating the some language using
Yeah.
some prompt, right? Then obviously I
Yeah.
will suggest you it can be adaptable, whether it is classification, whether it is clustering or like some other task. For any task you can adopt it. Currently we have adopted for the summarization, but it is like you can because I will share the code with you. You can maybe slightly change and adopt this.
Okay. Okay. Thank you, sir.
Yeah.
Any other questions? Gunesh, any other question from your side or anyone? I don't think so. So anyway, thank you, Dr. Naveen. So if anyone wants to contact you, definitely directly they can contact you, or through me also will contact you, and you just share the PPT and this GitHub code so that I can share with the students.
Yeah, definitely I will share with you.
So anyway, thank you very much. I will be in contact with you for some.
Yeah, thank you so much, Professor, for inviting me.
Thank you.
Should I leave now?
Yes, yes. Thank you.
Okay, bye everyone.